Hi everyone, myself Amrutha, Assistant Professor from Department of Computer Science, St. Albert's College, Autonomous. Today we are going to have a session from Advanced Data Structure, that is how we can insert an element to a simply linked list. So in the previous lecture which I have already told you what is a linked list and what the different types of linked list and all. We already discussed a simply linked list and all. So I just give you a brief about what is a simply linked list. In a simply linked list, it is a collection of an ordered set of elements. That is, a simply linked list, which is a linear data structure which containing each nodes will be having a data part and an address part. The data which will be the actual information stored in the memory, and the address which is a linking to the next node. So this is an example of the simply linked list where you can see here multiple nodes are present here. The first node which will points to a head and the last node which be pointing to a null value, and each node will be having a data and the address to the next point. And this is a simple structure of a simply linked list. So now let's see how we can insert element to in simply linked list. So insertion to a simply linked list can be of three cases. First one, insertion at the beginning, insertion at the end, and insertion at the specific location. Let's discuss these three cases in detail. The first one is insertion at the beginning of the list. So this is the algorithm which we want to perform at the insertion at the beginning of the list. So my first step, that is creating a new node with a given value. That is, first of all you create a new node, right, which the element you want to insert. That is, first of all create a new node with a given value. Now let's want to check whether the list is empty. If it is empty, by using the condition head is equal to null. Why you are using head equal to null is the first node which we are pointing to head. So that we are using this condition head is equal to null. So by this condition you check whether the list is empty. So if the list is empty, you can directly set the value as new node next can be set as null, and also head is equal to new node. And if the list is not empty, you want to set as new node next is equal to head and head is equal to new node. This can be checked through an example. So this is the first case. In this case, the list is empty. Here I am going to insert an element 10 to the list. So what all the steps want to be done, which I already told in the algorithm part. So first of all, you want to create a new node with a given value. That is, here the 10 is a given value. So first of all, create a node with 10. Then what you want to do? You want to check whether the list is empty. This is the first case, that is list is empty, you already know. So what you want to do? That is, you want to set this new node as head, and also you want to set new node next value as null value. So these are the two steps you want to be performed if the list is empty. So first of all, create a new node with a given value, that is 10. Then assign this new node as head, and also you want to assign new node next as null value. And this is the second case, that is when list is not empty. Here in the list which is already having a 10. Now I am going to insert 20 to the list. So what are the steps to be performed? So first of all, we want to create a new node with 20 with a given value as 20. Then what I want to do is I want to link these two nodes together. I want to link after 20 I want 10. So that you assign it as new node next as head. This is now only first node is pointing this one, only having a single node, so that this is a head. So you set as new node next as head, and you want to reset this head, so that new node assign head is equal to new node. So these are the steps for the insertion at the beginning case. So while you are inserting at the beginning, first of all create a new node with given value, and then check whether list is empty. If it is empty, you can directly insert into the list. So directly set as head is equal to new node and new node next as null. But if it is not empty, you want to set as new node next as head and assign the head is equal to new node. So now let's see how the insertion can be done at the end. So now let's see how we can insert the element to the end of the list. So these are the algorithm to perform the insertion at the end. So first of all, you create a new node with given value and set the new node next as null. Here I am initializing here new node next as well in null in the first step itself, because which I already know I am going to insert the elements at the end. So all the element node which is at the end will be pointing to the null value. So that in the first step itself I can initialize its new node next as null. Now in the second step you want to check whether list is empty or not by using the condition head is equal to null. So if it is empty, then set head is equal to new node and you can terminate the function. If it is not empty, you want to define a pointer called temp, because we want to identify the last node. So we want to traverse until the last node, then only we can insert at the last. So you define a node pointer called temp and initialize with head, and keep on moving the temp until the temp's next is equal to null. Then there we can get the last node. Now simply assign as temp next is equal to new node, and now the insertion at the end is over. So let's identify this through an example. So in this case, here already this is our list which is not empty. So here 10 and 20 is there. So I want to insert 30 after 20. So first of all, create a new node with a 30 and set as 30 is next as null. Now I want to give this link. So I want to identify, I want to traverse and move on to the last node. So for you just initialize a node pointer temp and initialize to head, and keep on moving traversing the temp until temp's next is equal to null. So the temp will comes to the last node. Now here the last node which having a temp, and we can just give the link, that is temp's next is equal to new node, and thus the insertion at the last can be done in the linked list. Now let's see how the insertion is possible at that specific location. How can we do? That means if the specific location means it can be of first node, or it can be of last node, or it can be a middle case also, it can be there. So how it is possible can be done through this algorithms. So first of all, it is saying that is the first of all, create a new node with given value and then check whether the list is empty or not by using head is equal to null. If it is empty, you already know that is new nodes next can be set as null and point that head to new node. If it is not empty, we want to define a pointer called temp and initialize to head, and keep on moving temp until how much you keep on moving is after the node which we want to insert. You keep on traversing the temp, and you want to check whether the temp if the node may be present in the list. So if it is reaches the last node and not present, you just terminate the function. Or if you, after the insertion, you perform that new node next as temps next, and also set as temps next is equal to new node. Just I using an example, you can see here. This is an example. Here this is our list, and I want to insert 15 after 91. How you can do this is, first of all, initialize temp. That means define a pointer called temp and initialize to head. So first in this first case, head and temp is pointing to the first node. Then keep on moving the temp until the node which we want to insert. Here I want to insert after 91. So move up to 91. The temp value is now at the 91. So here 91 having temp value, and this is our new node. So now give the links. That is temps next. I want this new node. So here temps next is equal to new nodes next. So just give that link, and also this link also can be performed as temps next is equal to new node. These are the two conditions which we want to perform. So by this lecture, I think you understand how the simply linked list insertion can be done through three cases, that is insertion at the beginning, insertion at the end, and insertion at a specific locations. Thank you. And in the next lecture, we can see how the deletion can be done in the linked list.